right, so we have 2 resistors and a battery, and we want to use them to heat water. So the power that's dissipated by these resistors is going to generate heat, and that's going to be something that heats up our water. So to figure out how much power is going to be supplied, I have 3 equations for power. We kind of need to figure out which one to use. So we have that power is current times voltage. We also have power is current squared times R, and it also equals voltage squared over R. So we don't really know off the top of our heads which one of these to use. And the problem here is that R appears in the top of the equation here and in the bottom of the equation here. So it's going to matter which of these equations we look at for how we rationalize if we want to get power to be big. So before we do that, let's first figure out which one is going to have a bigger equivalent resistance. So here's 2 resistors in series, 2 resistors in parallel. Add more resistors in parallel, the equivalent resistance goes down. So smaller equivalent resistance for this one. And since I know that the current supplied by the battery is the EMF over the equivalent resistance, I know that that will be small and that will be big. So this one has larger I. So there's a few ways to look at this. You could just look at this one. So you certainly know that the voltage supplied by the battery is 9 volts in both cases. So that's the same in both. And the current pulled by the battery is bigger in this one. So we have more current, same voltage. So that one will supply more power. Yeah, that's probably the easiest way to look at that. So we'll just stop there. Okay, for the next is the equivalent capacitance of the combination of capacitors in the circuit. So I have that for series combinations, the equivalent capacitance is adds like parallel resistors. So it'll be 1 over C1 plus 1 over C2 to the -1. And for parallel, equivalent capacitance is going to look like that. So the first thing I see is that these 2 are in parallel with each other, so let's combine them to be 1. So we'll go like that. We'll keep our 3 and replace those 2 with just 1. They are going to add just like that, so 5 plus 1 is 6, and that will be 6 microfarads. So now we have a circuit with only 2 capacitors on it, and they are in series with each other, so it'll be that equation. So the equivalent for the entire circuit is going to be 1 over 3 plus 1 over 6 to the -1. And it's definitely a good idea to practice doing this on your calculator. I'm sure you've done it plenty of times at this point, but it still manages to mess up a lot of people. So if I do this in my calculator, I get 1/2 to the -1 power, which is 2. And I should write that to 2 sig figs.